on, Algebra Bros, it's Mr. C here, and in this video we're going to go ahead and review how to graph an equation by plotting points. But first, a little bit about this blurb up here that you're seeing. The graph of an equation in two variables, typically x and y, consists of the set of points in the xy plane, or plans, didn't notice it said that, my apologies, whose coordinates xy satisfy the equation. So it says, as we carry on, knowing the values of x and y that satisfy the equation allows us to graph the equation in the coordinate plane, thereby helping us to see the relationship between the two variables. Okay, so what does that all mean, right? What's the plain old English on that? Well, basically what it's saying is that the graph of an equation is really just made up of all the points whose coordinates satisfy the equation. So for instance, we had this equation right here, 2x plus y equals 5. So we could, guess and check different pairs of values x and y to figure out what satisfies the equation. For instance, if you want to come up with one off the top of your head, we could have x be 2 and y be 1, right? Because 2 times 2 is 4, plus 1 gives us 5. So that would be a point that would be on the graph of the equation because it's a solution to the equation. Alright, but what happens if the equation is more elaborate, or if you need to come up with more and more points, lickety-split, right? So one of the first things that we could do to help us get a really quick graph of this equation, or a picture of the solutions, is to go ahead and isolate one of the variables in the equation. I think the easiest one to isolate would be y, so let's write y equals, and basically you just subtract this 2x over to the right. It becomes negative 2x. And I'll place that in front of the 5 that's positive. So here we have basically a rewrite of the equation where y is isolated, and the benefit of having it written this way is that we can say, alright, well, let me just pick some random values of x, and once we plug it into the equation we can get the corresponding values of y. Basically what that means is as soon as you pick a value of x, you can just plug and chug, get a value of y, and bam, we have a point that's on the graph because it will automatically be a solution to the equation. So if you've done this skill before, you probably know that if you want to graph an equation by hand, one of the most useful tools is to use a table of values. So over in this space here, let me go ahead and set up a table of values. And there's going to be 3 columns to it. The first column is where our chosen values of x will go. Our second column is how we're going to get y, which remember y is found by doing negative 2 times the x value and then adding 5. And then once we crank that arithmetic out, we'll not only have x but we'll also have y, which we can form an ordered pair to plot because of that. Alright, so what values of x should we use? Well, it's really up to you. Just to keep things simple, I'll use what I often refer to as the Fab 5, which are integers that go from negative 2 to positive 2. So for instance, the first value of x that we could start with is maybe negative 2. And so once we have x as negative 2, we can go ahead and plug it into the expression here to get what the y value is. So what we'll do is negative 2 times negative 2 plus 5, and that gives us 9. So when the x value is 2, the y value is 9, that means that the point that's going to be on the graph because of this is negative 2 comma 9. Next value of x, negative 1. Go ahead and plug it into the equation for y, so it's going to be negative 2 times negative 1 plus 5, which boils down to 2 plus 5, giving us 7. So another point on our graph is negative 1 comma 7. Then 0, pretty easy number to use, negative 2 times 0 plus 5, and that gives us 5. So 0 comma 5 is another solution to the equation, which of course is another point on our graph. Continuing on, if we choose x as 1, it's negative 2 times 1 plus 5, which gives us positive 3. So another point on our graph is 1 comma 3. And then last but not least, 2. So negative 2 times 2 plus 5. Okay, so that's going to be negative 4 plus 5, giving us 1. So another point on our graph is 2 comma 1. And you can continue doing this more and more, choosing different values of x. And quite honestly, you don't have to confine yourself to just the integers. You could use some decimals such as 0.5 or 2.75. But generally speaking, when you get enough points going in your table and you plot them and you can see kind of the pattern of the graph, there's sometimes not really a true need to include more and more points. But in other cases, there is going to be a need to maybe include more than just, the Fab 5 here. So it just kind of depends on which equation you're working with. All right, so let's go ahead and plot some of these points. I'll do it in red. Well, if we start with -2, 9, looking at our coordinate plane here, assuming that the spacing between each tick mark is a 1, -2, 9 is not going to fit. So we'll just go ahead and skip that for now. And it looks like -1, 7 is not going to be plotted in our coordinate plane either, because the y-coordinate is too large. Of course, you could rescale the tick mark, so on and so forth, but I'm just going to keep it nice and easy for us in this video. Let's go to 0, 5. That actually is a point that we can plot. So we'll start at the origin. The x-coordinate is 0, so we won't go left or right, but we will go up by 5. Alright, so that's the point 0, 5. Next point is 1, 3. So start back at the origin, go to the right one, and then up by 3. And then 2, 1. So back at the origin, we'll go right by 2 and then up by 1. And I think for good measure, what I'd like to do is go ahead and insert maybe another value of x here. Let's maybe do 3. See what the y value is. -2 times 3 plus 5. So that's -6 plus 5, giving us -1. So here comes another point on our graph. 3, -1. Start at the origin, go to the right by 3, and then down by 1. Alright, and I think that's plenty of points for us to figure out what the pattern of the graph is going to be. Just go ahead and change pen colors here. Alright, so it looks like these points are kind of flowing in the pattern of a line, and you probably knew that in advance. Yep, this is the graph of a linear equation. We'll talk more about these in our next section, but what we'll do now is just connect all the points, and we'll also extend. So let me start with this point right here. Alright, so as wiggly as that is, it is supposed to be a line. And of course, if you wanted to use more and more x values, say beyond 3, you would see the pattern of points continue in that direction. And if you wanted to use more and more negative x values, you'd see the pattern of points continuing up in this direction. So, excuse my human error, wiggly, snaky line there, but this is supposed to be a straight line. And that'll actually conclude the video, because we graph the equation by plotting points, which is also known as a by hand method. Alright guys, so thanks for muscling your way through this video. Of course, let me know if you have any questions about it. Otherwise, I'll see you in the next one. Thank you.